and welcome into yet another live stream. And today it will be a walk stream, not a rest stream. That was yesterday, but today it's time to walk. And so, hi the pseudonym, hi the Michael, and bye Michael, and bye, and hi the rest night, bye, hi, welcome. Welcome. And hello, actually, oh yeah, as always, I started unprepared, because obviously I did. Even music. Well, the fundraiser's linked up, that's good. Even music. There we go. There we go. And there we are. Work. No, I want work. Work. Damn it, I have to learn how to speak. It's like, I know I have an accent, my goodness. No need to point it out. Hurtful, farmer main, really hurtful. But it only hurts because it's true. It stings because it's true. Anyhow, today I thought we would work on for some reason that sounds wrong. On the video, the elementary particles video to be exact. And I thought that we could actually jump ahead a bit to the lepton chapter. To like parallelize the walk a bit more. The walk bit. Ah, jeez. I'm awful at this. Talking mostly. There we are. Okay. So leptons is chapter 1. No, it's whichever chapter, I think. Elementary particles, like chapter 4. Okay. Leptons, where is it? Where you at?
Every now and then in science, you
No, that's color charge.
This is already gonna be a pretty long video.
Yeah, 60 minutes halfway through.
Leptons differ from.
There you are. Okay. So leptons chapter. Leptons, okay. Intro elementary particles, where is it? You basically polyveritasium. Quit calling me that. Never, not once in my entire YouTube career have I done anything that could be regarded as Polish. Can't I just be the European Veritasium? I want to broaden the demographic appeal, you know. It's all for money. That's why I'm doing this, of course. Everyone knows it's the reason. Okay. Oh, there are some cups in the way. There we go. There we go. So, quarks will be chapter 1. Is it chapter 2? Intro quarks. Not really. Electromagnetism, I guess, would be the next one. But I can clump it together with leptons. Leptons. And electromagnetism. Leptons. Hi there, Lucas. Hi. Polish PBS space-time. I mean, the end goal would be to just apply the knowledge that I don't really have money yet. This is really good looking, isn't it? I'm not gonna lie. I don't mean to toot my own horn here, but I very much do. I've done an amazing job with this. It does crash my PC every now and then, so if the stream stops abruptly, that's then you know why. But I've done an amazing job. Up quark, down quark, charm quark, strange quark, top quark, bottom quark, electron, muon, tau, neutrinos, gluon, photon, Z boson, W boson. W boson is more complex because it's kind of more important. This one's kind of only for neutrinos. And Higgs. It's lovely. Having a streams, hope you're doing well. Hi the bee, welcome. Have you done a blended donut tutorial yet? You mean done a donut in Blender or made my own tutorial? No, I'm a beginner at Blender. I don't think I could do a a donut, you know? It seems a bit too difficult. Leptons differ from quarks in two major ways. Okay, so right here we have our leptons, which we'd like to move. We can get rid of the Higgs, the carrier particles, don't care for it. And for quarks, we only mostly want... Actually, we could just bring all 6 of them. Why not? Alright, now we would like a nicer scene, certainly, because as neat as this is... Like galaxies in high concentration of color, kind of, especially neutrinos, right, this. Oh yeah. Crystal balls are just such an easy way to make things look nice. We need some sort of floor, some new kind, because I've already been overusing this in the quark segment. So, I sometimes forget you can do that in Blender. I hope that the glue will be rainbow. Oh no, what an oversight! Oh, how come have I... Oh no, what an oversight! You're so right, it should be! Oh, it just hit me! It's so... Oh, it should be rainbow! It's the gluon, it's color charge! It's basically color charge particle! Oh no! Wait, what did I even make for a gluon? I don't remember. I don't want to re-render all of it, but I might. You are so right, this should be the rainbow. I remembered about the wave particle duality for the photon, but... Genius connection. I mean, I'm honestly really upset that I didn't think of it myself, because it so very much should be rainbow. Oh no! It's fine. I can fix it in post quickly. We're just gonna glue on update it. No one's gonna bat an eye. Glue on is just gonna get a color later on, and no one's gonna bat an eye. Right, it's gonna be all good. It's gonna be fine. So that's... Oh, the second you said it, it just hit me how obviously better it would be for it to be a rainbow. Alright, hue saturation value. Give me a red. I'm a bit... I need to wake up. I just woke up, so it's early in the morning for me, so... I haven't yet stretched my blender bone. Emission color right here. No, we want this to be emission color. And then noise texture. I feel like Voronoi would be better. But not that kind of rainbow, that's gross. That's just gross. Come on. No, we need a better kind of rainbow. We don't want that either. We want much bigger. Or shift through color spectrum. Huh. I could, but then I would need to... The thing is, I really like the idea of all of them being static, because then I don't need to render every single frame. I can just render one and extend it. Which, well, you know, we are working with a time constraint. I do want to make weekly uploads, so unfortunately that kind of has to be a limit. But what I could do is actually take the noise texture. Give it something like this. It doesn't look great, does it? My nanotechnology and electronics masters, I need to relax, was so exhausting. How did it go, Baduan? How did it go? What are your thoughts on scotch with orange juice? Oh, first of all, I'm not much of a drinker. Second of all, scotch with orange juice? Is that the real thing people drink? Oh, defeats the purpose of scotch. Unless you're talking about different scotch or orange juice, in which case I'm not familiar. So that sounds like someone trying to be posh, playing off with a screwdriver. Now, yeah, it still looks like garbage. Because yeah, obviously we could just have it shift through the color. What do you think about vodka with Fanta? There's gotta be a better way than with Fanta. What's the purpose of that drink? Vodka with Fanta. Oh no. God, that... Why? Vodka and espresso. I mean, is that something like espresso martini sort of thing? I don't know. Vodka and espresso. That sounds like... Well, I mean, if we're gonna have fun, might as well be productive, I suppose. I just made it up before my misinformation. I doubt you would be the first person to make it up. I think someone in history has tried it before. What happens if we do a completely unrelated noise texture? That's much better. Kick up the saturation. Yeah. I like it. I do like it. I don't hate it at the very least. That is so much better, my goodness. Some of them was nice, some of them not. They asked things about optoelectronics devices, and I could only say quantum dots. They make me explain semiconductors at PNN type, I guess I managed to do. And in the electronics interview, they prefer asked the vectors, and the guy was brother of the inventor of 5G coding. Oh boy, well... But still, at least he's behind you. That's good, that's good. I believe in you. I believe Baduhan. Was it drinking age in Poland? I think 18, isn't it? I'm pretty certain. By the way, is there a specific reason why particles look the way they do? You mean my artistic interpretation? Yes, there is actually. I've put a lot of thought and effort into it, in fact. Why they look the way they do. Like an unreasonable amount of thought and effort into symbolizing what every single one of them is. So basically, all of these are top quarks, so they have positive charge. All of these are bottom quarks, so they have negative charge. The more right you go, the simpler the pattern, Voronoi pattern inside becomes, because these are more massive, these are less massive. However, these are much more massive than these, and that's why strange quark is so complex, to symbolize the fact that it's less massive one of the second generation. Then we move on to leptons. The more right, the brighter they become. That's because the third generation, the more unstable they get. Each one of them has its lepton version and has its neutrino version, which is kind of like a tuned down lepton. Then right here, gluon, well, only now Feynman just told me that it really should be rainbow, which is obviously, it should be rainbow, because it's a color charge, so obviously. Photon is obviously wave-particle duality. When it comes to bosons, Z boson is less complex than W boson. That's because W boson is the actual gamer of the W and Z bosons, in my opinion. Basically, W boson is responsible for weak force, Z boson is responsible for mostly just neutrinos, as far as I can tell. And then Higgs boson is just completely different. On the side, solid color, that's because it's mostly there to represent the field, which is kind of responsible, kind of a biggie. It's cheap antidepressant. I don't think alcohol is an antidepressant. I don't think it should be classified this way, since I don't know if you've noticed, but if someone is sad and they drink, they usually get sadder. They don't really. It doesn't really help with depression. Just because you black out and you don't remember doesn't mean you're still not. No, it's not really an antidepressant. If anything, it's a depressant. YouTube conversion does not like the blender. Oh yeah, right, because I am doing it, and that makes sense. But anyway, right here we have both of these. Y coordinates. There we go, and Y coordinates. There we go. Now we can move this up. Now we can move these more to the side. Like so. And now we can take all of these and parent them to the camera. There we go. Here's where we'll start our comparison. Now we can delete everything that's not necessary. That is, this isn't necessary, this isn't necessary, this isn't necessary, the other camera isn't necessary, this isn't necessary. And the plane wanna change the texture. Hide the rare blacks. Make Higgs boson into a small weird shape. I don't know, no, because Higgs boson is really not about the boson, it's more about the field. So as a particle, it's not quite as impactful, it's more like the consequence of the particle. No, look at these. I am good at what I do, aren't I? My goodness. These look so awesome. These look awesome! I drink to forget I drink. If we really think about it, subatomic particles should have no color. I mean, if you want to go this way, subatomic particles can have color, I guess. Like, they do interact with a photon. Elementary particles, maybe not, because I don't think quarks... Well, I guess quarks still interact with a photon. Actually, I guess elementary particles, there's an argument to be made that they have color. There is an argument there. And that color would be something like... X-ray... No, it wouldn't be even X-rays, it would be really higher. You know, just light of extremely tiny wavelengths. Spiritus is a good disinfectant. Doesn't... No, I could disinfect. Fun fact, that's what I used in my chemistry video for the fire. That's just alcohol. What is this video? Where's Thunblade? Isn't this a video about elementary particles? Those are the elementary particles. And floor, let me just, you know, let's replace it with something simple. I don't care. I don't care for it. Brick. Brick it is. Oh boy, goodness gracious me. Pop in the metallic. And actually muff, like... Yeah. Increase the metallic of it all by, like, multiply 3. At least. It's not gonna work because the light is right on it, isn't it? What if we increase the... Yeah, there's a texture mode. Oh, that's what it is. That makes sense. Okay. Let's increase the brightness of the background. There we go. Now we can make this darker. Sweet. Do I drink, sleep, or watch a stream? I think sleep is the solid choice there. When things reflect back from those different wavelengths and hit their icons. Yes, but I said that there's an argument to be made because protons, or quarks even, still interact with photons since they have charge. I think, technically. I don't know how they interact, but they would have to. Polish Vsauce, my goodness. Subatomic particles should be too small to reflect more than one electron at a time. You mean photon, but no, they're not too small. They aren't too small to interact with them. My god, I keep getting distracted. Displacement, that's one last thing I'd like to add. Did I mention that if... Hold on, height. There we go. That looks pretty neat, I would say. Visible too big for quarks to interact with. That is true. That is true. It can't interact with visible light. Although, no, actually, I don't... Well, for quarks, yeah, okay, for quarks that's true. However, if you want to just say elementary particles, then that wouldn't exactly be correct because technically, well, not even technically, all of the reflections that we see happen due to electrons, which are elementary particles. So, when, you know, atoms reflect, or molecules, when they reflect color, what actually is happening when they reflect light to create color, what's actually reflecting the light is the electron. And so I suppose all we can see is elementary particles then. The fact that quarks blend line between constant and of course, because they have different. Leptons don't have a color charge, so right here, what we could do is we could just render it. Actually, no, let's put that in an angle. I feel like that would look better. There we go, that is much better. And sweet. Sweet, sweet, sweet. There we go. Now it feels like awkwardly at the bottom actually. Move this to the left by negative 0.5. Move this to the right by 0.5. A photon has spin 1 and electron spin half. So photon's only twice as big as electron, one of the smallest subatomic particle. I would like to screenshot your comment and I would like to send it to Flame, who is my my chemistry expert, because I really would like his take on the matter. I can't tell the quarks apart. Well, it's because they are similar. It's kind of the whole deal with quarks. Why we call them quarks. Jima overcooked a bit. The thing is, that's not quite what spin is. Give me all of these. There we go. Move them up. Doesn't feel better, does it? Oh, probably because they're not upright. That might be it, actually. Kind of would like 90, 0, 0. Then bring him down. Pseudonym! For goodness sake, can't you just let things go? Oh my goodness. That came out of nowhere. Yeah! Yeah, that's pseudonym. Just keeps coming back to... Oh, I don't even know. There we go. Now one last thing, cherry on top, if you will. Save it as a backup, and then unparent these. Remove any keyframes from 0 to 10. Depth of field. Oh, depth of field is already enabled. I beg to differ. Where is the depth of field then? Oh, there is a depth of field. You're not wrong. So that is so far. Let's do 0.5 because... Whoops, let's do 0.5. Oh, the distance is just this great. I love how much Eevee with the default viewport shader settings is struggling with these volumes. Uh-oh, there we go, we're back. Let's lower it down even more. Like 0.3. No. My taskbar! I swear, Windows, one day I am going to just absolutely end you. You might be a Polish knight, but I'm not that good of chemistry yet, unfortunately. The background feels a bit too bright, doesn't it? It certainly does. Alright. Render image. Sweet. Although I feel like there's a bit too much room up there, you know? Maybe if I move the camera a bit lower down. There we go. It's changing your power profile and GPU profile. Not fully rendered yet. Unfully definedness of the quantum ward. I don't feel like... I don't know if that would be appropriate though. They're already noise textures, basically. Actually, I feel like I should go quite the opposite. Look at this. See all these artifacts? That's because I'm rendering 16 samples, that's why they are there. I can also bring this up to 7. I feel like that's good enough. Now if I render it with 256, it's gonna take a much longer time, obviously. But the artifact should be gone. Yeah, it's noise of the samples. Basically, the more complex your shaders are, the worse the noise gets. Yeah, there are still some artifacts there, but I feel like it's good enough at this point. On the right is a bit worse with this. This shouldn't be blurry, rather quite as blurry. And these should not be dots. But oh well. Lepton's electromagnetism frames.
Leptins. Leptins differ from quarks in two major ways. Leptins differ from
Yeah, there will probably be some sort of animation to go in.
Leptins differ from quarks in two major ways. First one is that leptins don't have a color charge, meaning that they do not interact with the strong interaction. That's the first.
Alright, so right here we'd like a fairly short animation, something like 50 frames I suppose, where we'll have two quarks and just two leptins. Let's just get them to be electron both. They're both gonna come to camera. -12 and -1 or -2. -1.5. -2. -1. There we go. And then nope, not duplicate. -12 and 1. Gonna keyframe both of these, keyframe both of these. Now they're gonna come forward. And one more thing is the distance, to make the background even more blurry, to make it more distinguishable. Actually, it's gonna be 14, correct? Yeah, because it's 26 minus 12. There we go. And one last thing, might as well move the camera a bit up, because actually that might have been a mistake. I will have to look at them to see the color charge, but oh well, happens. And there we go, now 25 minutes to render this animation, everyone. I already regret setting it to 256. Let's change it back to, maybe not 16, but 32, because oh my goodness, it's gonna take a bit. There we go, much better. 7 seconds. Or 9 seconds. 9 seconds, okay. 9 seconds to render. Hi the DS, welcome. 9 seconds to render times 50, that gives us 500, not bad. Have you figured out how to represent color charge? I have. That's actually the first thing I did for quarks. That's why quarks took me such a long time to make. Precisely in order to represent color charge. And it's actually pretty decent representation, I would say. Now these animations will be more fun to make because, well, we're just gonna start including stuff, and right here we'll be talking about how electrons behave, which is fun too. This is gonna be a fun video. This really is gonna be a fun video. It's Friday today, if I'm not mistaken, which means I have 2 days to finish it. Oh, it's fine. All I need is 2 days, am I right? I hope I'm right. Fermilab? I'm not familiar with Fermilab. We can't say that I am. Who's Fermilab? You're cooked? No, I'm not cooked. I am the one who cooks. Hold on, if cooking, like in, you know, in, I know what to call it, teen talk? I know what it's nowadays. If cooking means doing something well, right? Like, oh, you're cooking, you know, that means doing something well. Why does getting cooked, why is that negative? Shouldn't getting cooked be, like, positive too? You got cooked. Why is that negative? Oh yeah, that is where it came from, isn't it? Breaking Bad, I think. Look at me, Flame. Someone knocks on your door and chucks 50 moles of electrons at you. It's me. I am the one who cooks with electricity. I don't know, I feel like Flame is the one who's actually chucking electrons. I mean, Flame right now is probably busy chucking electrons, so... That's what he's doing. Oh, the reflection. There are some people trying to convince me that I should use EV instead of cycles. But I mean, how could I ever? Look at this. Ah, it's phenomenal. To be fair, it does take a fair bit to render, you know. But, yeah. Random meaning, primary meaning, and implied meaning, and many more I don't recall. Good still, am I right? There we go. This is rendering. Almost finished, just 25 more. So 200, so 250. So 244.5 minutes. Anyhow. What's the music from? That's AI generated. Some languages are context sensitive. Aren't all languages context sensitive? They're dependent on the context. Unless you mean it, unless it's something different. The problem is every single animation here will be in Blender. Muon and Tau, they're just like, okay, what's this then? Cousins of the electron. Muon and Tau just, this all requires continuity. Gouge bosons, I could make that animation, but... AI generated, yeah, it's all AI generated, based on the Make It theme. So right here you can hear it. That's Make It theme reimagined, or whatever you want to call it. What do the Christmas tree ornaments represent? I don't know. How would I know? It's kind of weird to use a top and the bottom corks up and a down one. But I mean, oh well.
One is that leptons don't have a color charge, meaning that they do not interact with the strong interaction. That's the classic difference. But another one I'd like to focus in is...
Okay, so right here we're just gonna have a camera. Oh, this is gonna be such a long animation to render. Piss. Oh, okay. Normally I would take this time to... This is actually really tricky. Damn it. Mercury of elementary particles decoration. That's science and hypothesis tree, not a Christmas tree. When I'm sick, don't send thoughts and prayers, send research and hypothesis. When we make a video about programming languages, can you touch those topics in the history section? I don't think I'll have a history section in my programming languages video. That's because with programming languages, I don't know how interesting of a history that is. Like, when it comes to technology, there are certainly interesting histories. Like, for example, the history of a cookie is wild, and Mozilla Firefox, too, it's a wild history. But with programming languages, it's a bit more boring. Oh no, no. Big problem, why no one warned me? I did just absolutely render it in the wrong folder. Whoops. That's where you were supposed to be rendering it. And then right here, gonna have to move it. There we go. Fixed.
First one is that leptons don't have a color charge, meaning that they do not interact with the strong interaction.
Okay. How does languages evolve may be interesting, but that's so boring. That is so unbelievably boring. It's the same reason why I normally don't do I don't do videos on history of science. Because there are interesting stories in history of science, but history of science as a whole isn't interesting. So I will make some videos about stories of science, but hi there, Cronmiss. Turing complete. Oh no, I prefer to just do logic in oxygen not included. I feel like that's much better. 200. That's gonna be a quite long one to render, but basically the reason why it's gonna be so long is we're gonna start with a certain rotation, and we're gonna look at both of these, and then we're gonna have a gander at both of these, and we'll see that they do in fact have a color charge. Why is it so sharp? Just move it down a bit, my goodness. That is busy, isn't it? Why can't you just be a bit more, like, chill with it, if you will? There's another way I could do this, but it's not a great one. I don't like how you, in your fundamental forces video, made relativity look better by only mentioning downside classical conduct and gravity. Relativity is worse than the other two. What a claim, Gemma! That's a wild claim, because relativity is the theory we currently use when doing science on classical scales. What do you mean, worse? What do you mean by worse? Auto-keying, right. My goodness, that's awful. That's why I don't use auto-keying. It's really difficult to auto-key properly. Relativity doesn't explain why mass energy bends space-time. This Einstein expects us to believe magic make it happen. Well, Gemma, neither does classical gravity. Classical gravity doesn't explain. What's more, you could make the same argument. Quantum gravity doesn't explain why gravitons exist either. That's common. That's not exclusive to relativity. We have the same thing with electromagnetism. We don't have an explanation for why photons exist. That's actually pretty normal. Diffuse assumption still matches up the reality, but yeah, it's incredible actually. It requires diffuse assumptions. It's the most general, hence name general relativity, and it's like general to a comical degree. There are practically no assumptions in general relativity. It's incredible. It works better than classical mechanics. We finally got to the point where we can actually measure the near speed of light and high energy scenarios required for us to actually see the difference between classical and relativity. Quantum gravity doesn't make sense because you cannot renormalize the gravitons, so that's kind of wrong. So yeah, relativity is currently the best theory we've got. And I would argue it's not really close. Can't you just be smooth with it instead of just... Welcome to music, my goodness. I don't know if that's better or worse. Feels better. It feels worse, okay. Actually, I feel like it would be easier to just linear it and then Bezier it. Gravity zone, why do you need to renormalize it? We know particles can influence other particles, so gravitons make more sense. Well, relativity assumes the existence of space and continuum as interaction with a separate entity, which is BS. Space-time continuum is not comparable to anything else we have seen in physics. Gemma, but we know particles can influence other particles. That's an odd way to make an argument. We know that space-time exists. We do, and space-time continuum is not much of a stretch. Gemma, I feel like you just don't understand relativity in quantum mechanics. Because relativity actually has fewer assumptions than quantum mechanics. Way fewer assumptions. Quantum mechanics is actually the weird one. For example, the word quantum, the fact that things are quantized. That's pretty odd. That is, to say the least, quite odd. But it makes sense for photons, for example. Or rather, it's not really that it makes sense, more like we have seen that it works in photons. Of it like 2/3. And then right here. Actually, let's have 1/3. And then right here, let's have 0. There we go. Gravity is weird and particles having failures based on energy. Particles having discrete quantum numbers is already wild if you think about it. I see photons every day without needing to understand quantum mechanics. You're not wrong. The thing is, we have proof of relativity. as in gravitational waves, to say the least, or time dilation experiments, to be even more extreme. Time dilation, experimental testing of time dilation, we have this proof. Gemma, okay, but then let me ask you another question, Gemma. What is time made of? What is time made of? Because with your line of logic, we should discredit any physical model that includes time. Because what is time made of? Magic? What? Oh, you mean to tell me these scientists now would like to pretend that time exists? Oh, how silly. Oh yeah, there's this like magical dimension apparently that works in a different way, or change happens across it. You see how there are certain things which just have no underlying explanation. A great example being elementary particles. Quarks aren't made of anything, they just are. Leptons aren't made of anything, they just are. Electromagnetism isn't made of anything, electromagnetism just is. Strong interaction, weak interaction, and gravity. Over there we also have space, we also have time. Time is not real, time is just a measure of change motion in space. Change motion relative to what, Gemma? When you have a derivative of a function of x, you need that derivative to be relative to you need that change to be relative to something, relative to one another. But when you... not really. If you have a cube, if you try to create a universe without time, Gemma, if you have two cubes, right? Yes, I'm drawing cubes even though I'm in Blender. If you have two cubes, if you measure their distance, without time, that distance is just going to be constant. There's not going to be any difference. You need time in order for you to actually measure change. And time doesn't really have anything underlying to it. You need t. There is no way for you to define t other than just to assume that it exists. The thing is, Gemma, space-time continuum being is just a fundamental thing. It doesn't have a reason for existing, and it's not weird in physics, as I mentioned. With your line of thinking, you'll have to pretend that quarks don't exist, electrons don't exist, that a strong interaction doesn't exist, electricity doesn't exist, gravity doesn't exist, that space doesn't exist. I mean, as in space, you know, like the position. Time doesn't exist. There's a lot of things that won't exist if you just assume that things can't just exist without an underlying explanation. There's no quality cubes. I know, I am exquisite. Nothing like making 2D drawings of 3D stuff. When I assume motion and space as fundamental, consider time as relative measure of motion to space. Well, you can, but then space-time continuum wouldn't really just be a space-time continuum, it would just be space inverse by motion. Like, in our current understanding, we have space-time, which is just x, y, z, t. But if you have motion, then it's very much still... well, technically we don't really have t, we have like change, and that actually happens in physics sometimes, Gemma, but that's just a walk around to define time in a different way. Because if time isn't fundamental, then motion has to be fundamental. You agree with Gemma? It's really odd, in my opinion, to be against relativity, because we know relativity works best. That's not like a question. We know. It's not really a matter of question because we use it. So we know that relativity works best. Is it the right theory? Well, we don't know that, but we do know that it's more right than classical gravity and quantum gravity. We know that for a fact. Simply because quantum gravity fails. it just fails. Quantum gravity may seem simple on the surface, but it just doesn't work. Like, a good analogy would be, it would be easier for us to imagine photons as particles, you know, as just dots traveling in space, but they're not. We know for a fact they're not because the dual slit experiment tells us they are not. Not fundamental quantity like length is derived, in my opinion, is the biggest. Alright, Gemma, let's go your way then. How would you define length if not define it by itself? If you say that length is fundamental, then what's happening there? You mean tell me that we just have length is magic then, isn't it? It's fundamental. No, you just have to think most of it. Well, Dunning-Kruger is not quite the same. Dunning-Kruger, this will play here. Time didn't exist before inventing clocks. Yeah. Actually, John Time. Oh my goodness. Remember John Time? Yeah, John Time actually invented time in the year 0 BC. That's why it was 0, because John Time. Length was made by Big Ruler to say tape measures. Length is fundamental because you aren't dependent on other quantities like time to measure it, but you need space to derive time. Time is change divided by space. Gemma, you can make that argument the other way if you want. It's not difficult. I could say the same thing. Look at this. Time is fundamental because you aren't dependent on other quantities like length to measure it, but you need time to derive length. Length is change times time. See, you can just change it around if you want. It's just as valid. What you are basically saying, Gemma, is... allow me to show you. What you are basically saying is that time isn't fundamental because time is defined as... well, change as basically velocity in this case. Is... wait, velocity is equal to... you said change divided by space, so velocity divided by length. But I could just flip them around and say that length is fundamental because length is defined as velocity divided by time. That seems wrong. First of all, I don't think it's velocity divided by length. I don't think it's change divided by length. Shouldn't be... it's divided by time. That's incorrect. That's the first thing. It's not change by space. Velocity is equal... length divided by time, which means that time is equal to length divided by change. There we go. And then length is equal to time multiplied by velocity. Time is more absurd. We don't have time in maths. We need both change and space in physics. Well, in maths we don't have length either, but in physics we do have time. Given, yes, we most often refer to change in time, but the reason why time is easier in this way is because you can just represent the position of any particle with a 4-dimensional vector. X, Y, Z, T. So when you're talking about the position of something, you're talking about its position in space-time. When you're talking about change of something, then you're talking about the 3 change vectors. Now there are 3 change values for a vector. I am rendering, don't worry. I feel like, Gemma, your point stems from a deep misunderstanding of physics. Because there is nothing... relativity is weird in comparison to classical mechanics, but classical mechanics is weird in comparison to relativity. I think that you just come from a good understanding of classical mechanics, but you don't realize that different theories will often make different assumptions. And that's something that happens all the time in physics. So, Another example would be quantum mechanics, right? Quantum mechanics also makes different assumptions than classical mechanics. That's because in classical mechanics, you have a field of gravity, which, once again, magic. But in quantum mechanics, you have a quantized field of gravity, which is still magic, but it's quantized. Can you represent time in maths without using length, position, or change in maths? Yes, letter T. Space can be represented by vectors and changed by matrices in maths, but try time. Time is derived from plane of space. Time can be represented by a vector, depending on how many time dimensions you have, I suppose, but also just a scalar. This is, I suppose, more of a one-dimensional vector rather than a scalar, because in our universe we just happen to have one temporal dimension. Oh, hold on, where is Remco when you need him? My goodness. We had Reblox. I don't know if... Well, I need Remco. Where's Remco when you need him? Because it's parallel to physical world, time and length do not mean the same thing in math and physics, because that's not the point. I know, that's why I need Remco. Because math only cares about the tools. That's the problem. We can't set a physics argument with maths, because maths will be just like, will be the truth centrist position. Needs to always have a constant magnitude as well, right? This is physical, but has no physical meaning. You need a positional vector space to represent position in math. So it's a fundamental... not dependent on anything. Matrices help us note change in space. Time is derived from plane we use to graph the change in space. Well, Gemma, now you're spilling over misunderstanding of both physics and math, because in math, it's not quite the distance you think of. In math, you can sometimes say distance, as in abstract distance in a space of possibilities, for example. That's something that happens... So, Gemma, that is something that happens in math. For example, in AI research, AIs have their own space of possibilities. So, like, space of options, and then distance in that space refers to like the difference of options. But that's abstract, and you can do that with time too. Gemma, imagine this. You have a two-dimensional world, right, with stickmen. You have this two-dimensional world on which stickmen live. Now imagine that we add a temporal dimension, which means that in this world you would have three coordinates: x, y, t. Two spatial coordinates and one temporal one. Now, if you imagine a cube like this, then what this basically means is that each point in that cube, in that three-dimensional cube, in that cube, has to be specified by three numbers. It's x spatial coordinate, y spatial coordinate, and t temporal coordinate. That's what coordinates are. In our universe, it's the same thing, except we also have a third spatial dimension. We have x, y, z. I admire you engage in pretty much any and all questions that come up, Chad, being to explain things through like you did with mastering for me. I'm glad to help. I am glad to share my love of science and my knowledge of science. You don't need fourth time coordinate in a three-dimensional universe. do you need it in a two-dimensional? Because if you do need it in a two-dimensional, if you don't need it in a three-dimensional, then what you're basically saying is that there is something different about three-dimensional universe, which is a pretty bold claim, I would say. I would argue it's a pretty bold claim. Actually, Reblax, you know what? I'm sorry, Reblax, you know I don't mean it this way, but unfortunately we don't have Remco, so I'm gonna have to use your mathematics to settle a physics argument. It's not gonna be pretty, but let's do it. Reblax. Oh, how am I supposed to word it? Because I feel like... Actually, Reblax, maybe you could explain it. Like, abstract position. Because I think what's happening here is that Gemma is confusing physical position with abstract mathematical position. So, that could actually be good. Gemma, imagine a three-dimensional space of possibilities in which you have... That's actually an example from the video about elementary particles I'm right now making. Imagine a three-dimensional space of possibilities, right? With 3 dimensions, where the first one represents bananas. Beautiful banana, as you can see. Second one represents apples, which is just gonna be green. And third one represents oranges, right? Now, in this, from a mathematical point of view, this is a three-dimensional space. This is mathematical concept of space, right? Mathematics. Big M, because it's important, it's mathematics. What this basically means is that you have a vector, a three-dimensional vector like this, in which each number corresponds to a different fruit in this case. Which means that if I have a vector like 3, 7, 2, what this will mean is 3 bananas, 7 apples, 2 oranges. That's a mathematical concept of abstract space. I'm certain there are other names for it too, but I have heard referred to it as space. Space of possibilities, space of fruits, space of whatever. That's mathematics. In physics, however, it changes. Because in physics, when we're talking about space, we're talking about... Thank me for... Remco! Remco, my goodness! Oh, finally! I have been... yourself on stream. Remco! Took you long enough. Remco, Gemma thinks that... I mean, okay, you are biased because you, for some reason, really like gravitons. But Gemma thinks that gravitons... Actually, I don't want to construct a strawman here. So, but problem is, Gemma thinks that, first of all, time isn't real in physics, only it's a derivation of change. And second of all, Gemma doesn't think that relativity makes sense. Or rather, yeah, still under construction. Also, wouldn't I flame you for doing linear algebra in the voice chat? Gemma makes sense, but Make It is trying to mislead here. I literally did just say that I didn't want to say it because I don't want to construct this strawman. I don't think... The problem there is that you are trying to argue something which goes against our understanding of physics. If we take time, rate of change is positional vector, as fundamental, then rate of change will also be fundamental. We'll have infinite fundamental quantities that way. No, we'll have just... Time and space can rotate into each other. There we go. So, Gemma, basically, time can only be seen separately from space in low velocity limit. There we go, solid! Oh, I love just having a physicist on hand. So basically, that's kind of what I was trying to explain with the mathematical concept of space versus the physical one. Basically, if you want to separate Oh, I did x, y, z, y. If you have x, y, z, t space-time, then it's incredibly odd to me to just separate time for no reason. Space-time vector, just custom magnitude. Can you explain the low velocity time separate part? No. It does not treat time on an equal footing. Oh, that's interesting! I've never heard... I always thought it was the renormalization on the as in the limits. Well, there we go, Gemma. Can you explain the low velocity time separate part? I'm also curious. Moving faster makes you longer. That joke is relatively funny. Shouldn't you be working on the weekly upload? Farmer main, I am. I really am. I can't speed it up much from there. It's rendering. That's why we can chat. It's rendered by this time. Oh, absolutely not. Absolutely not. It's how many seconds per frame? It's 11 seconds per frame. Does not rotate into space anymore, so any moment in time direction will only be in time direction, so rotate in space dimension. That's actually really cool. That time is only different if in a low velocity limit. Well, Gemma, does that answer your... not quite question, was it? Too advanced for me. I mean, the basic idea is simple. The basic idea is just that if you move really quickly, the difference between temporal and spatial fades away. And it's just a dimension. A space-time dimension. Maybe time is the friends who made along the way. Exactly. When you can't explain them, confuse them. I don't think it's confusing. This is pretty tame by physics standards. This is pretty tame. Is ds squared is equal to negative c dt squared plus dx squared. Oh, that's such a cool equation though. Hold on. No, that equation deserves to be formatted correctly. ds squared is equal to negative c dt squared plus dx. Oh, but that deserves to be formatted better than I can do here. Hold on, let me just bring up my... Oh, that equation. How come I've never seen that equation? I always mention how my how my research into relativity was always just dipping my toes in. Hold on, that equation is way too cool to not be boiled into text. Ah, that's so bright. ds squared is equal to negative c dt squared plus dx squared plus dy squared plus dz, I'm assuming squared. So time can rotate in space and vice versa. That's such a neat equation. Shows the rotation between space and time. That is badass. See? Oh my goodness, I am so glad to just have a Remco lying around. There we go. There we go. Gemma, are you convinced? And Pseudonym too, because Pseudonym, you said that you also agree with Gemma. Are you both convinced? Science Pokemons when needed. This thing. I'm not intelligent enough for physics. Don't say that, Acronymus. Don't say that. I was simply trolling. Alright then. Well, Gemma, are you convinced? Proud to be a math-type Pokemon. This is my pot of... when I'm just struggling with science, explaining science, I just cast my pot of greed and summon the Exodia in the form of Flame, Remco, and Reflux. Witchcraft, find the ice, do some magic in witchcraft. I'm convinced. Okay, I'm glad then. Because the thing is, there is a lot of cases, that's especially the problem with advanced science. The more advanced you get, the more confusing it seems on the surface. This is especially a big problem, and right when it rendered, beautiful timing. This is especially a problem because there is a lot of... It's important to... This is the awkward thing about science. On one hand, you shouldn't trust science. That's kind of the point, right? You can't trust it. Like, none of the scientists actually trust any science. That's why they just keep retesting and rechecking everything. But on the other hand, you don't want to distrust things you don't understand because there is equal, well, not quite equal possibility, it's kind of the pickle. You could either misunderstand something because it's too advanced, or you could misunderstand something because it's wrong. So it's the awkward double-edged sword. Which is why it's convenient to have experts like Remco laying around. Einstein also never had bad grades in math. Did he not? That's just grades. Yeah, but that was in the before times, you know. Both experimentally observed. That's what I like about relativity, because it's unbelievably general assumptions and then determination of grades. Well, Acronymus, if it's any constellation, if I do remember correctly, is any constellation, space joke. If it's any Flame also didn't have great grades with chemistry. And now Flame is just shooting lasers at rocks, so, you know. That's basically Einstein. Grades are just there to please the professor, exactly. Who is the biggest fool? The one who doesn't have any answers but denies a clear explanation, or the one who accepts? I think it's Edison. It might have been Edison because Edison sucked as a human being, and I'm just not surprised to learn that Edison would suck in math.
Polar charge, meaning that they do not interact with the strong interaction. That's the classic difference. But another one I'd like to focus in is that quarks blur the line between a concept and a thing. You see,
How am I supposed to visualize it blurring a line between concept and thing? If Einstein failed with math, we were all doomed. You don't really need to be an amazing mathematician to be an amazing physicist, nor do you need good grades to be an amazing mathematician. Being a mathematician is repeatedly failing at math over and over. I feel like this is being a scientist, isn't it? Being a scientist is repeatedly failing at science. The thing is, the reason why relativity is so outstanding, in my opinion, isn't because of the maths, it's because of the generality of it. It's kind of the three things we're trying to merge in physics is the quantumness, the relativity, and... oh, what was the third one? The theory of everything. It was relativity, quantum, and gravity, I think? Was it really just gravity? It might have been just gravity. Just quantum field theory plus general relativity. Well, yeah, but, you know, there's a kind of a pickle with that, isn't it? Would be nice if it worked. You know what's bonkers to me? How... it really still is bonkers how we considered gravity to be a fundamental interaction. Considering how easy it is to merge relativity with any other fundamental interaction. Or rather, how easy it is to merge relativity and quantumness in any other interaction. Photons, for goodness sake! Like, we just... but photons basically have a theory of everything in them. But it only works for photons. Photons is relativity, perfect merge of relativity and quantum mechanics. And we just like take that for granted. It's mad. It is a fundamental interaction, but it's certainly an odd one out. Like, it's a fundamental interaction in the sense that there is nothing more basic describing it, but strong and electroweak both work on a... It's because general relativity you assume smoothness of space-time, which does not hold below the Planck length. You mean to tell me that you can't something be... You mean to tell me that when something is both discrete and quantized, and smooth and continuous, you can't just have both of these at the same time? Oh, Remco, no, you physicists are just... no way, come on. Just, it's simple, it's just quantized and also smooth. Well, what's the problem there? There's nothing anywhere else really strange. Execution from all three physics. Hold on, actually, I have one question for you, Remco, because I am curious. That's because I like never seen it answered, but I feel there must be some reason. I must be wrong in this case. Why isn't Higgs a fundamental interaction if it just like provides potential, you know, for mass? I know that the equivalence, right, of inertial mass and gravitational mass is there, but it's still different, isn't it? Shouldn't inertial mass be a fundamental interaction? That would just be the Higgs interaction. Or am I wrong here? Why isn't electron a fundamental interaction? Well, because it's not a field, is it? That's my... I mean, I don't know if I'm imagining it wrong, but... electron field for the win. Ah, oh, you physicists. Actually, mathematicians there more, I would say. Electron field is the horror child of mathematics more than physics. Can inertial mass be different from gravitational mass? Technically yes, and technically no.
focus in is that quarks blur the line between a concept.
We could just have it break. Oh, that would be so impossible to actually animate.
Blur the line between a concept and a thing.
I do have one fun idea. We need to remove this one though. 210. Move this left. There we go. Let's have a few of annihilation creation operators. Bless quantum field theory, none of them are fields. Higgs boson field, what gives particles mass? Interaction of particles with a Higgs boson, what gives particles mass? That sounds like electroweak. None of them are forces. It was weak. I'm not certain. I'm guessing. I'm just saying it sounds like the electroweak force because of the, you know, because of it dividing in lower energy. Very smart of you. With two options, if I guess the correct one with absolutely no certainty, that is the definition of intelligence. If you just have a coin flip and you guess its tails correctly, that means you're smart. Can we not do politics and instead discuss the much more sane field of physics? I agree. I agree. Shush, very smart of you. I really want to understand why electroweak gets divided at low energy. It's madness, the energy thing in physics. How at higher energy is just different. I'm assuming it's going to be something like the Lorentz factor. It's gotta be something like that. There's gotta be something like Lorentz in relativity. But I'm still really curious, because it's madness. It's really cool. We can do both, like political science. Yeah, but political science would require us to not do politics, only do political science, which I don't think any of us here are qualified to do. You wouldn't download the quantum force. The quantum force. I agree. Physics is 50-50, are both right and wrong, yeah, and you can't tell until you open the box. I am curious to see how this ball will react when I do the liquid simulation. It's gonna screw itself up a bit. This is humanities. The problem is, the more abstract you get with sciences, the more difficult it becomes for it to be rigorous. That's why with physics, we can be... Like, with maths, we can be absolutely certain of something. With physics, we can be really, really certain, but the higher you go, the more certain you lose. So even in organic chemistry, you already have exceptions. With medicine, it becomes really, really difficult. With psychology, it's basically impossible to be certain of anything. And then with stuff like economics or... Well, economics being a good example. With economics, you more like describe trends rather than deduce them based on, you know, individuals. Humanities can be rigorous too, but on different principles. Not on the same level as low abstract science. It's not even close. So, for example, like, even the most rigorous claim of any humanity... Economics is a social science. Yeah, I use it as an example of, you know, abstract. There must be more fundamental geometric properties space themselves rather than solely consequent with the presence of matter and energy. Equivalency theory? Do you mean the equivalence principle, or is there a whole theory called equivalency theory I'm not aware of? Equivalency theory. Oh, you know it's gonna be good if all you get is just... Oh, fun! Can I have a nicely formatted PDF, please? Because I am... You know what? I'll take any win I can get. Emerging theory of distance equation and equivalence learning. Usually presents an interesting approach for distance education. I can't even tell what... I don't think that's what it is. I don't think that's what I'm looking for, is it? Einstein equations, actually. I'm doing that, I don't have 5 minutes. Just average all the theories and find their answers. Okay, hold on, let's turn this off. And now it's time for the fun one, because now I want to see how my shader will react to it getting simulated. Boy, oh boy, this is gonna be fun. Did it work? Where's the... I'm sorry, convert... No, wait. Quick effects, quit liquid. Oh, it just broke. That's good. Cool. Alright, fluid. Wait. One more time. Anyone knows what the definition of insanity is, by the way? I'm just wondering. I'm funny that way. Okay. Let's go fluid, let's go flow, if I'm not mistaken. Not smoke, only liquid. Geometry. Yes, geometry. Now, cube. Oh wait, it's gonna be the main, isn't it? Oops. Like if I do 210 to 400, is it gonna walk? Make a chat drama. We already had so many extreme dramas before. There, sweet. It worked on the first try, which I'll be honest, I'm quite glad with. Because it doesn't always work on the first try. Now I would like to turn this off. And then give it the quark. Oh, this might crash if I give it. Quark top. Okay. Oh, I am just so awesome. I am so amazing at what I do. The only problem is that it's... Oh, never mind. The actually center of... The center is calculated in relation to geometry. Oh, that's amazing. Why is the quark becoming a soup? Because that's the only way I can think of to represent the fact that it's a concept. Or at least that it started as a concept. Pseudonym, please, take your meds. I want my viscosity, right, that's what I'm trying to do, I think. Maximum particle something. Where is the option though? Oh, I don't know. Viscosity, diffusion, high viscosity. Okay, there we go. 0.5. I don't know how much 0.5 is. We'd have to bake and see. Pharmacy, take their meds. Wasn't even straight wrong with civil Apple theory. Yeah, like, I'm just saying, but there certainly is a trend where the larger the object you imagine, the more correct you will be in physics. I'm not wrong. Newton imagined an apple, Einstein imagined a person falling. Or that Newton, you know, got hit by an apple, Einstein just imagined a person. Or maybe Einstein threw someone off the roof? Do we know? By Newton gravity, more like by Newton gravity. Hell yeah! You may like gravitons for some reason, but at least we're share in the... Well, not quite hatred of classical gravity, more like making fun of classical gravity. Okay, now give me 128, because might as well. That's such a bad idea. Uh-huh. Well... One frame. Not... I'm done. I'm done with doing it this way. 64. Why's the message censored again? I don't know which one. There's the 64. The high viscosity solver is also kind of... Person to start in high school instead of the stupid Newton gravity. I mean, yeah... I guess I think the reason why... No, I think the reason why people don't want to do it is because it's just... You know, it's only very narrow. You would need extremely high energy to actually care about difference, which just sucks. It just sucks. I can't give him this, doesn't have a prescription. Yet women are beyond your understanding, pseudonym. We live in a universe. That's enough energy. That's not nearly enough. I need more. Energy and joyous when entropy walks into the room. Wonderful pharmacy. You can send it into the science memes channel. I'm also curious to see it. Science meme channel is the best. Trying to answer women's misunderstanding yourself. A skill issue is what I would say to that. Oh, that's a good stretch. Oh, don't crush on me, Blender, now. No. You started this fluid bake, and by golly, you're gonna finish it. Whether you like it or not. Got to click the accept button. Yeah, I should really... Oh no, it's a YouTube video. I can't watch it on stream because it's illegal for me. It's called content stealing. Punishable by at least a $10,000 fine. As an entropy enjoyer, I think we have enough energy. Entropy enjoyer. No, that's not a group of people. I refuse to accept that entropy enjoyers exist. You answered your mom very well. Entropy should be the most hated thing by everyone equally. No one should enjoy entropy. That just ain't right. That ain't right. It ain't normal. It ain't logical. There we go. Please be a reasonable bake. That's not what I would call reasonable, you know? I like. That's not what I would call reasonable, you know? You just splattered my quark on the floor. Oh, fudge sticks. Fine, 0.05 it is. 64 or 32, might as well. Actually, let me just do 6, just a tiny bit more, because it was a bit... splattered a bit too much last time. Eventually, I was told by grandfather Nurgle, no, no, don't accept the safety of the decay. No, don't listen to him. Actually, I'm pretty certain that Slaanesh, you know, Sons of the Emperor, they had like a philosophy where apparently they really wanted entropy because the more extreme the axe, the more entropy it introduces. Why did it just break in such a weird way? Top. Why did you... Why? Why this way? Huh? But I like how you, when you splatter, the glow is still there. What I don't like, however, is how big the freaking thing is. Or it's how small it is, rather. There we go. Don't play with the fabric of reality, Garfield. Gosh. No, Garfield. It would be kind of convenient. Yeah, it's like the only thing in physics which you can only do one way. It sucks. It's also statistical physics, so you know. I really do like this animation. I really do. Alright, render. Infinite string of gluons between two quarks. Remco is never seen as hot by other men, so she relies on entropy and other excuses. I don't know if Pseudonym isn't taking their meds, or if Pseudonym took them all. At the same time. But the physics can't even manage to separate a single quark. Actually, yes, that's wild. I am curious, because the thing is, that's what I find so interesting about quarks. We consider them elementary particles, but we never actually interacted with a quark, did we? We more like interact with the strong interaction, and quarks just fit as a theory, which is so insane. It's so impressive that physicists could just come up with a theory like quarks and have it be correct. It's madness. Ow, I've cut myself in the head when I drink. Oh, madness, what do you... Every single advanced physics theory is just madness on paper. Every single one of them. Relativity, quantum field theory, basically every single elementary... Higgs, freaking... Oh, where does the mass come from at such low energy? Higgs, because why not? electroweak, which can actually just appear at high energy, just lower its electron. Spin in elementary particles, that's also there. There's just so much. Mad is in mind too, not just on paper. Yeah, but on paper is the one that you release into the board. It's normal to confuse genius as madness, and it's normal to confuse madness as genius. It goes both ways. It goes more often madness to genius rather than genius to madness. It's easy because genius is verifiable, actually. That's the easy bit. You can verify someone's genius. I suppose you can also verify someone's madness. Such a great binding energy that I want to try to break. That's great. You're gonna bind the quark. The infinite cycle repeats. Little force elves make up atoms and they like to spin. King Fu, genius. Genius. I'm adding it the best quotes channel, best comments channel. Stealing it. A yoink. There we go. Atomic force microscopes. Wait, sorry, what? I'm sorry? Atomic what now? Atomic force microscopes? Atomic how and what now? Okay, it's still laser. Never mind. No, I thought it was like this. I thought it was like we were measuring stuff using the nuclear force, which I got excited. I mean, it makes sense. Might as well skip the middleman, right? If you're gonna have a photon interact with something, might as well just replace it with a physical object. A half spin is perfectly normal, apparently. Yeah. No, Remco is exclusively made up of gravitons. Remco transcended the need for physical form. I suppose it's still physical form. Automatic cell repair mechanism. I mean, it's not really quarks, is it? It's more like hadrons. Except they can change, I guess. I guess not. Of all the charm quarks. Ah, there's just some nice balls on the screen, aren't they? My goodness, I've done a good job with them balls. That set me. Ah, splendid. Pure gravitational manifestation of utter imagination. Yeah, you just... The force of attraction around you is so massive that it has to be just pure gravity. Way to call me heavy. No, hold on. Would pure gravity be heavy? I don't... Because on one hand, it would have the same effect. On the other hand, it wouldn't really have mass. Is gravity heavy? Hold on. It just hit me how... Oh, how actually kind of mad it is that Newton came up with gravity. If you consider the fact that, like, that was centuries before we actually, left Earth in any way, so there was no actual... Oh, it was kind of mad, wasn't it? We had telescopes, I suppose, but still not the kind we... Oh my goodness. I really often underestimated Newton, but coming up with gravity this early is actually kind of impressive, if you think about it. Is gravity even real or just an imaginary force created by the fact that the geodesics are curved in curved space-time? That is gravity. Depends how you... Oh! Is gravity even real? And... Oh, wait. Acronymous, did you just ask me if gravity is real because... because of the curved... Oh, my goodness. I wonder, is gravity even real? That's a good question. Like, is gravity isn't real? Is like curvature of space time? Would that make gravity real, or would it not? Because I don't know. Oh man, that's a good question. Newton was crazy for saying gravity on Earth is the same as gravity in space. That's what I'm saying, right? That's like mad. What the heck? I don't know if Newton is underrated anymore. I mean, overrated anymore, actually. I don't... Like, I really often said that Newton was overrated, simply because, like Einstein, like, they were impressive. But... that is actually kind of mad. It's the same way it makes Planet 10 is insane. Yeah, it just now hit me. This is wild. The surroundings and stuff more complicated and interesting. Kind of like how programmers keep a shotgun just in case they're printed as something weird. How was gravity calculated in medieval times before Newton? I don't think it was considered gravity. I think it was, if I do remember correctly, it was just considered like a nature of the universe. As in, you know... You remember how before atoms we thought that everything was made up of fire, water, and earth? I was there. I remember those times. Those were good old days. Well, the same thing was kind of for gravity. Things falling down was seen as like the... Actually, we went full circle, didn't we? We started by thinking that gravity was just like... I mean, not gravity, only things falling down was like a base thing of the universe, and we end up with gravity, which is a fundamental interaction. Kind of a beautiful circle if you think about it. Light of a fire is the same as light of a star. Some light of a star, not all of it. Depends, because in stars you also have... in stars you basically have every single kind of energy you possibly can from atoms released at once. Stuff falls down, because down there's hell, obviously. Chemical fire is fusion plasma. No, but you still get normal fire in stars. I mean, I guess it would be fire, if you think about it, actually. It would still just be fire. It's just that the source of energy would be different. Depends how you define fire, I guess. Oxidation or release of energy. I know if defined fire will give me what I want. Fire. My goodness, what's wrong with me? Fire! Chemical change that releases heat and light and is accompanied by a flame, especially by extended oxidation. Oh, so it's persistent chemical change that releases heat and light. I mean, there is chemical change in stars. There's not the most dominant. The nucleus more. Evil homework is done. Expansion of space. Anaconda of space created or what? Expansion of space is also one of these odd things because it's just a thing that happens. I need rent for notes. Space increases our Remco mass increases every week. Do I don't think do gravitons have mass? Oh, it can be weird. Graviton. In a hypothetical model, would they have mass? Oh boy, they would. Electron volts. 6? 10 negative electron volt. That's not a lot of mass, actually. Hold on. Up quark, whatever, just something. Up quarks have 2.2 mega electron volts. That's not a lot of mass. How would you even detect gravitons, actually? Because they only interact with gravitation and... they are theoretically massless. Oh yeah, that makes sense then. So at most they would have the smallest amount of mass possible. That's the problem we face, make it. I mean, I know. The whole dilly of how gravity is just extremely weak. Difficult to detect them. Okay, we did detect neutrinos. Don't worry about the fact that, you know, weak interaction is actually like 10 to the 20 times stronger than gravity, don't mind that. We did detect neutrinos. Also, another thing. Hold on. No. Let's not gloss over that. Hold on. Remco, if you have a particle which can only interact with gravity and has no mass, would you consider that particle to exist? Wouldn't that effectively mean that it doesn't interact with anything? Because, like, if they interact with gravity but have no mass, how would they interact with gravity? Leave a graviton mousetrap. Genius. Can we extinguish sun if we put enough iron in it? Kind of. Weak nuclear force, maybe, I know. No, because it said that, well, hold on, did I turn it off? No, I didn't. It said that the interaction is gravitation, only gravitation. With all the particles you get, I don't know if it's for quarks actually, because they have color charge, but for example, muon, if you take a muon, then you have interactions, gravity, electromagnetic, weak. If you take a neutrino, then you have interactions, weak, and gravitation. For right here you have only gravitation. I don't know if I would consider that existence. If you have a particle that just interacts with nothing, that just sounds like nothing. Oh, hi, Funky. I'm so sorry for not saying hi. Hi. How do you know it's you? That's what I'm saying. Particles that only interact with gravitons are labeled as dark matter. That would wreck the whole understanding of everything, wouldn't it, though? Because then we would need, like... if you have no electric charge, no color charge, no interaction with weak interaction, only gravity, but you also have no mass, so you can't interact with gravity either. Or rather, you can't... well, I guess it's not that weird. I guess photons have no charge, too. I guess it kinda makes sense. Yeah, I take it back. It makes sense. It would be same as Photon. Would be what you are looking for, I suppose. This is the whole point of existence, to explain gravitation. Yeah, and people are, and the scientists are failing at it. I'm sorry, but we have a bit of a feud with Remco. I am a relativity enjoyer. Remco is a graviton fanboy, and every chance I get, I just rub it in the fact that, you know, gravitons actually don't exist so far. As you know, am I doing any better? I'm sorry, I can't hear your theory, unproven theory with a bunch of problems over my proven relativity, Remco. Oh, I'm sorry. Oh, I'm sorry, I'm too busy using relativity in real life to GPS and whatnot. At least we have a theory. Oh yeah? Yeah? How are you gonna... how do you plan on detecting the gravitons then, huh? In your theory. That's my own version. That's my physical version of the mole. In chemistry, I just... I shit talk moles. In physics, I'll just shit talk gravitons. What experiment could there even be to confirm gravitons existing? I mean, I'm assuming there would be. You would just need an incredible detector. It's my favorite in quantum. Yeah. Taking is up for the adventures. I mean, not quite. I wouldn't say so. Because for detecting, you could do it two ways. You could either have it as an engineering problem, as in, you know, make a big enough detector and a detector that's sensitive enough to actually detect the graviton, or you could develop a theory which allows for a mechanism to detect them. Does nobody calls you Kitty Renko? Pseudonym? Who had you? Just... my goodness. How would the photon interact with graviton if it's massless? I don't think we... I actually don't... How do we detect neutrinos? No, neutrinos aren't carrier particles, are they? How do we detect gluons? I'll just make RQFT. I'll just make RQFT casually. That Hawkins guy had no idea what he was doing. I'll just make RQFT. Yeah, Remco could do it. To be fair, if anyone's gonna make a theory of everything, it is gonna be Remco. Because who else? Graviton proof via sounding cool. Honor, dear Honor, nah. Consider that. And then drops mic and then... I need Roblox to keep it mathematically consistent. Remco, I'm just saying, it would be kind of rude of you to not come up with a theory of everything, because I really want to have someone who watches my videos win a Nobel Prize, and so you're kind of, you know, it would be pretty rude of you to not win a Nobel Prize. I'm just saying. I'm not asking for much here. I give you free content in the form of videos, you just need to win the Nobel Prize. If I find a new particle, I'll call it the Megatron. I'm all for it. I would make a whole series of videos about the Megatron. I would go so in depth. Don't we have 100 theories of everything already? Kind of, not quite. It's from the Markitron. I'll take it. I'll settle. If you name a particle after me, I will acknowledge graviton as being a viable theory. That's my deal. Take it or leave it. Not very free if you demand the fucking Nobel Prize. Oh, come on. It's science videos for a Nobel Prize. That's a good deal. The Graviton, remember to make it run. That would be such a way to own me, though. Can you imagine? Me making fun of the Gravitron all the time, and then Remco just discovering it, naming it Maketron just to rub it in. To attempt to remind you of your failure. Nobel Prize actually pays you though. Oh yeah, but it wouldn't be Nobel Prize for me. It would be Nobel Prize for Remco. I just demand that Remco gets it. It's cheaper than free, exactly. Take it from Destroyer of Gravitons. Money good needs to go to science though. I mean, I suppose that's a fair assumption. Will a Peace Nobel Prize suffice? Fine. I love how, by the way, Nobel Peace Prize started as this important thing, but even though it started as this important thing, right now it's not even considered to be a full Nobel Prize. That's because it's just so much easier to get a Nobel Peace Prize than it is to get an actual Nobel Prize in science. And then was Fortran provide theorem about super mutations. I remember something about that, yeah. Scientific proof via revenge is more common than you think. I mean, this is the ultimate way to own someone, isn't it? Just create the theory. I call me pharmacy intro because pharma made is awkward, you know. There are two MAs in there, and that's just too many MAs. Stick to one MA, like a reasonable person, you know. Cultured. You only need one MA. To yield this conjecture. I mean, that is all you need. You do only need a single counterexample to disprove something. It's kind of the whole point. That's kind of a whole point. If you have a theory which assumes something to always be the case, then you know you just need one counterexample to show that it's not always the case. Pharmacent. There, single MA, that's good. Ends in T, that's also pretty solid. B- for that name. As American have a long day of Guns and Burgers tomorrow. Good night. Bye. Have a good one with Guns and Burgers. I understand. It's a duty. I know. Sleep well for good night, King. No, I think I'm gonna go too, actually. I'm getting a bit hungry, and I need a shower, so... It's been a 2-hour-long live stream, it's been solid. We almost rendered 3 animations. That's something. Yeah, I'll just... Well, it will render quicker off stream, because, you know, my graphics card won't have to do the streaming, or CPU. And suppose, for now, that'll be it. Thank you everyone so much for watching, and have a great day. Bye.